Welcome back to my digital diaries. In today's video from our Frontend developer course, we deep dive into React series with an essential topic, virtual DOM. Make sure to watch this video till the end, and if you find it helpful, don't forget to like, share and subscribe to the channel. Let's get started with virtual DOM. Have you ever wondered how JavaScript can change text on a website without reloading the page? How a button click can instantly update content? The answer to all of this is something called the DOM, means Document Object Model. Let's understand what DOM really is and why it is the backbone of a dynamic web application. Formally, if you define DOM is a programming interface that represents the structure of a web page as a tree of a node. What does that mean in simple language? When your browser loads an HTML page, it doesn't just show it visually. It converts the entire HTML into a structured tree like an object in a memory. That structure is what we call the DOM. So DOM is not your HTML file itself. It is a live object created by the browser from your HTML. The most important concept to understand is DOM represents the page as a hierarchical tree. It means it is organized just like a family tree. At the top, we may have the root element like HTML. Inside HTML, we might have a body. Inside a body, we may have a H1 tag, P1 tag. So this parent-child relationship is exactly how the browser understands your web page. Now comes the most powerful part of a DOM. DOM allows JavaScript to access, modify, add, or delete elements dynamically. That means with JavaScript, you can change the text inside H1 tag, you can hide or show P tag, add a completely new button or remove an existing image, change style like color, size, background, and all of this happens without reloading the page. This is exactly how animation also works. From validate instantly, live search works. So React, Angular, Vue updates the UI, all of that is powered by DOM manipulation. Now the important performance concept related to DOM. DOM updates are expensive because the browser must repaint and reflow the layout. What does this mean? When you change even a small thing in a DOM, the browser recalculates the position, it redraws the UI, it reapplies the layouts. That's why too many DOM updates or too many frequent DOM changes can make your website slow and lagging. This is also the reason framework like React use virtual DOM for optimization. Now let's understand the code example. When this HTML loads in the browser, DOM structure become exactly what you see in the diagram on the right. At the top we have a HTML, then below it we have a body, and inside the body we have a H1 and P1 tag. This is the DOM tree representation. Every tag becomes a node. Every text inside a tag also become a node. So the browser literally sees your page like a tree of connected objects. If the real DOM is slow, how do modern framework like React make websites super fast? The answer is virtual DOM. Virtual DOM is a lightweight JavaScript copy of the real DOM. Let's simplify this. Real DOM is same as your browser made structure, whereas virtual DOM is JavaScript made structure. So virtual DOM is not inside the browser UI, it lives only in the memory as a plain JavaScript object. Let's take an example. Now look at this diagram carefully. This is a real DOM. So in our HTML we have a div, input, class and value. This structure directly controls what you see. Now look at the right side diagram, that is your virtual DOM. It has the same structure, just that this value has updated. Okay, so value is equal to path. otherwise everything is same. So user has updated the value, so that's why this node is changed. Okay, the entire structure of virtual DOM exists only in the memory, not on the screen. React keeps this copy so it can compare changes before touching the real DOM. Let's summarize what exactly happens. You have a real DOM which get copied into the virtual DOM. So virtual DOM, new virtual DOM, React compares both the thing, find the patch, like in this example value patch is changed, and applies that patch to the real DOM. So real DOM is like writing with a pen in your final exam paper, whereas virtual DOM is like rough notebooks. You don't erase and rewrite your final exam sheet every time. You first make changes in the rough notebook and then copy only the final correct answer. That's exactly what React does using virtual DOM. Now the key behind all this is manipulating the real DOM is slow, but updating a JavaScript object is extremely fast. Why real DOM is slow? Because it causes a reflow, repaint, triggers layout recalculation, affects entire UI tree. Whereas virtual DOM is fast because it is just a JavaScript in memory. There is no layout, no painting, no browser rendering. So React smartly says first calculate in memory, then touch the browser only once. So till now we have understood what is the DOM, what is the virtual DOM. Now the most important question is, how does the virtual DOM actually work behind the scenes in the React? So look at the left hand side diagram under real DOM. We have div, h1 and h2 tag. This is the actual browser UI structure that user steps on the screen, and then there is a first step happens, render virtual DOM. What it does, whenever a React app loads for the first time, React creates virtual tree of JavaScript object representing the UI. What does it mean? Your JSX, your components, your UI element, all of this is converted into a virtual DOM tree in a memory. So it will be converted into the virtual DOM. This is not shown on the screen. It exists only as a JavaScript object structure. This is React's starting blueprint of your UI. At first rendered, virtual DOM and real DOM look exactly the same. So you can see the real DOM and the virtual DOM both are exactly same at first stage, where the React creates a virtual tree of a JavaScript object representing the UI. Then comes the second step, that is state update. Now suppose something changes in your app. For example, a button is clicked, or a counter increases, a new item is added, or a form value changes. This change updates the state of the component. Important rule in React is whenever the state is changed, React creates a new virtual DOM tree. So now what we have is old virtual DOM and the new virtual DOM. So if you compare this old virtual DOM and new virtual DOM, in new virtual DOM we have added h3. But this both the things, the old virtual and the new virtual DOM, both are in the memory. And there comes the third step, diffing algorithm. Now here is the React's brain. React compares old virtual DOM and new virtual DOM. This comparison process is called diffing algorithm. What does actually it do? It checks which elements are same, which elements are changed, which elements were added, which elements were removed. So in this example we have a div which is same, h1 is same, h2 is same, but h3 is new. So React now knows only h3 needs to be added. So the third step is diffing algorithm. React compares the new tree with the old one to find minimal changes. And then the final is fourth step, that is patch the real DOM. Now instead of updating the entire page, React updates only the exact difference in the real DOM. Now if you see our old virtual DOM, new virtual DOM, the exact difference is h3. Okay, so it does not touch div, it does not touch h1, it does not touch h2, it only insert h3. So this is called patching in the real DOM. Now look at the new real DOM at the bottom. It becomes div, h1, h2, h3. This update happens without page reload, without heavy DOM operation, without flickering, with high performance. Let's understand the performance difference clearly. If the React updates the real DOM directly every time, reflow would happen repeatedly, repaint would happen repeatedly, app would lag. But with virtual DOM, all calculation happens in memory. Only final difference touches the browser. UI become extremely fast and smooth. Virtual DOM is not magic. It's a smart calculation before costly browser updates. So let's clear the three most common misconceptions about the virtual DOM. The first one is virtual DOM always makes app faster. Many developers believe this blindly. If I use virtual DOM, my app will always be fast. Virtual DOM improves performance in complex UIs, but for a simple apps, direct DOM manipulation can be faster. If your app has only 2-3 buttons, just a few text update, simple interaction, then virtual DOM, diffing, virtual tree comparison, memory allocation, all of this adds extra overhead. In such cases, plain JavaScript DOM updates can be faster. Virtual DOM shines only when UI is large, components are many, state updates happens frequently. So the reality is it improves performance in complex UIs, but for a simple apps, direct DOM manipulation can be faster. Second one is virtual DOM replaces the real DOM. Many beginners think that if I am using React, the real DOM is no longer used. This is completely wrong. Virtual DOM is just an abstraction layer. The real DOM is still updated. You can say in simple language, virtual DOM is brain and real DOM is body. React thinks in a virtual DOM, calculates the changes and finally updates the real DOM. So without a real DOM, nothing will display on the screen. Virtual DOM never replaces it. It only optimizes how it is updated. So reality is the virtual DOM is just an abstraction layer. The real DOM is still updated. The third one is virtual DOM is unique to React. Another common myth, only React has a virtual DOM, and this is also not true. Reality is the other frameworks like Vue also use a similar concept. Let us check key features of virtual DOM which makes modern UI framework fast, scalable and developer friendly. The first feature is lightweight representation of the real DOM. Virtual DOM is a lightweight JavaScript representation of the real DOM. What does lightweight mean here? Real DOM has heavy browser object. Virtual DOM is simple JavaScript object in memory. There is no layout calculation, no painting, no rendering cost. React doesn't immediately touch the browser. It first works with a lightweight copy which makes all calculation fast and efficient. Efficient diffing algorithm to minimize the changes. Virtual DOM uses a highly efficient diffing algorithm. What it actually does is it compares old virtual DOM versus new virtual DOM and it finds what changed, what stayed the same, what was added, what was removed. So instead of updating everything, React updates only what is required. This saves your CPU, reduces memory uses, prevent unnecessary screen redraw, and this is the core performance engine of React. Third important feature is the batch updates to avoid unnecessary re-renders. Virtual DOM batches the multiple updates together. Normally, if you update UI 3 times in a row, the browser could re-render 3 times. But React groups all updates, processes them together, applies only one final render. This means you will get a fewer renders, better performance, smoother UI. This is why React apps don't flicker even with a frequent update. Fourth one is a declarative UI update. Developers only describe what the UI should look like. React handles how to update it. This is a very important shift in thinking. In JavaScript DOM, you manually select elements, you manually change content, you manually update styles. But in React, you just update state, you describe the final UI output. React handles diffing, patching, rendering. This makes code cleaner, more predictable, easier to debug, and less error prone. Fifth one is a cross-platform consistency. Virtual DOM works not only on web but also on platform like React Native. What does it mean? The same core React logic, same component model, same virtual DOM concept, but output platform can be different. It can be web development, it can be mobile app development, or maybe desktop app. When you combine all these features, you will get high performance, predictable UI behavior, smooth animation, scalable architecture, and developer friendly coding. This is exactly why React dominates modern front-end development. As you understand what are the features of virtual DOM, it will be easy for you to understand why virtual DOM improves the performance. First, it reduces the costly DOM operations by batching updates. So virtual DOM reduces the expensive DOM operations by batching the multiple updates together. Second point is minimize the reflow and repaints in the browser. So virtual DOM minimize reflow and reprints. So React compares changes in the memory and finds only what actually changed, updates only that tiny portion, which minimize the reflow and reprint. And that's the reason why React based UI feels smoother, lag free, and highly responsive. The third point is optimize rendering by applying only required changes. So virtual DOM optimize rendering by applying only the required changes. With virtual DOM, only the changed element updated, unchanged elements stay exactly the same. So no wasteful rendering. This is a selective rendering is the core optimization engine of the React. The fourth point is keep UI responsive even during a frequent state update. So virtual DOM keeps the UI fast and responsive even during frequent state changes. With virtual DOM, changes stays fast, UI stays smooth, and no blocking of the main thread. This is why React is perfect for a large dashboard, high traffic website, real-time applications. Virtual DOM improves the performance by batching updates, reducing reflows, applying only necessary changes, and keeping the UI responsive under pressure. Now that we understand how the virtual DOM works, the next important concept we must understand is React Fiber. What it is? It is the new reconciliation engine introduced in the React 16. Earlier version of React used a different reconciliation system, but from React 16 onwards, React introduced a brand new architecture called React Fiber. This is a new architecture completely changed how React processes updates internally. It allows React to break rendering work into small chunks and prioritize the important tasks. Earlier, React used to do all rendering in one single go. If the task was heavy, the UI could freeze, but with the React Fiber, rendering work is broken into small chunks. Important tasks like user input get higher priority, less important work is delayed. This results in no UI freezing, small task scheduling, and faster user interaction. Now let's understand what React Fiber actually does at runtime. It supports async rendering. React Fibers allows the rendering to happen asynchronously. That means React can pause rendering, resume it later, or cancel it if a higher priority task comes in. This makes modern React non-blocking and highly responsive. Next thing is enables priority based update. Not all updates are equally important. For example, typing in a search input is high priority than loading the background data. So React Fiber assigns a different priorities to different updates, so the most important work always happens first. Makes UI smoother or on slow devices. On old mobile phones or low-end laptop, heavy rendering can cause a lag, animation can slutter, but Fiber smartly schedules the work, so even on a slow devices, the UI remains smooth and usable. This is a huge real-world performance advantages. What it enables: because of React Fiber, some powerful modern feature become possible. Concurrent mode allows React to work on multiple UI updates at the same time. Pause resumes a switch between them, and this makes React apps feel instant and fluid. Time slicing means React breaks rendering into a small time units and gives the browser time to handle user actions in between. Because rendering is no longer blocking, animations stay smooth, transition looks cleaner, user interaction feel natural, so it gives you a better animation. Interruption and resuming rendering. This is one of the biggest superpowers of React Fiber. React can now start rendering, stop in the middle if something important happens, and continues later from where it paused. This was not possible at all in the old React versions. React Fiber is the brain behind a modern React performance and smoother user experience. And that's the wrap up our session on virtual DOM. I hope this helped you to clearly understand what is virtual DOM, and you must have understand why React is faster. If you found this video helpful, don't forget to like, share and subscribe to my digital diaries. You can also join our channel membership program. See you in the next topic, that will be props and state. Thank you.